Every single time you send an email or stream a video or even just load a web page, your data goes on this wild, invisible journey. So today, we're going to pull back the curtain on that secret trip and look at the rule book that makes the whole thing work. It's called the OSI model. Right, think about it. You've just typed out a message, maybe a super important email or just a quick text. You hit send, and poof, it's gone. It just vanishes from your screen, right? It feels like it just teleported across the planet. Yeah, it feels like magic, doesn't it? Just one single smooth action. But what if I told you that in that tiny little split second, your message is actually starting a super complex 7-step journey? Yep. Behind that one little click, there's this entire hidden world of rules and protocols that just springs into action. This is the secret language, the very foundation that allows our entire internet to work. So, that rulebook, that's what we're here to talk about. It's called the OSI model. You can think of it as the universal translator for the internet. It's the reason your iPhone can talk to a Google server, which can talk to a Windows PC, all without a hitch. It doesn't matter who made the device. This model makes sure they all speak the same language. So this whole thing, the Open Systems Interconnection model, was actually developed way back in 1984. Now, the key thing to get is that it's just a blueprint, a conceptual framework. It doesn't do anything on its own. Instead, it just lays down the law, It sets the rules so that a device from company A can perfectly understand a device from company B. That's what we call interoperability, and it's absolutely crucial. And here's the brilliant part. The model breaks down the super complicated process of network communication into 7 manageable chunks, or layers. Each layer has one very specific job to do. And here's the rule. A layer only talks to the one directly above it and the one directly below it. This modular setup is genius, really. It makes building networks, managing them, and especially fixing them when they break so much easier. Okay, 7 layers. How on earth are you supposed to remember all of them and in the right order? Well, network engineers have a classic, kind of silly mnemonic for this. If you start from the bottom, layer 1, and go up, just remember this phrase. Please do not throw sausage pizza away. Seriously, that gives you physical, data link, network, transport, session, presentation, and application. Works like a charm. All right, let's follow your message on its journey. When you hit send, your data starts at the very top, at the application layer, and it begins its descent, moving down through all 7 layers. This whole process has a name, encapsulation. And really, that's just a fancy word for saying that each layer wraps your data in a little package with its own special instructions. Probably the best way to picture this is to think of a super high-tech postal service. Your message, that's the letter you wrote. As that letter moves down the layers, each layer acts like a different department. One puts it in an envelope. The next adds a zip code. Another adds the street address. Each one adds a new wrapper to get it ready for its big trip. So let's walk through it. At the top layers, your message is just, data. Simple enough. Then it hits the transport layer, which chops it up into smaller, manageable pieces called segments. Think of them like pages of a long letter. Next up, the network layer slaps on the final destination's IP address. That's like the full city, state, and zip code for the internet. Now it's a packet. After that, the data link layer adds the local address for the very next hop, like the specific mail truck it's getting on first. This creates a frame. And finally, we hit the bottom. The physical layer takes that frame and turns it all into bits, the actual ones and zeros, the electrical pulses or light signals that are going to travel through the wires. Did you catch how the name for your data keeps changing? It goes from data to segment to packet to frame. That's not just to be confusing, I promise. Each name actually tells you what that layer's job is. A segment is just a piece of the whole message. A packet is bundled up specifically for routing across huge networks. And a frame is all about that one short hop to the next device in the local chain. The names themselves are like a little roadmap of the journey. Okay, so quick rundown of those layers again. Layer 7, application. That's the app you're actually using, like your browser. Layer 6, presentation. This is the translator. It handles encryption, compression, making sure data formats are right. Layer 5, session. This guy manages the conversation, opening and closing the connection. Layer 4, transport. This is quality control, making sure all those little segments arrive safely and get put back in the right order. And then you have the bottom 3. They're the heavy lifters, all about the physical trip. And this is where it all gets real. Literally. Everything we've talked about so far is just logic, right? But layer 1, the physical layer, this is where the magic of physics takes over. This layer is all about the hardware, The cables, the connectors, the radio frequencies for Wi-Fi. It's the part that actually turns those abstract ones and zeros into a real physical signal, an electrical pulse, a flash of light in a fiber optic cable, or a radio wave that can physically cross the planet. Okay, so now you know the OSI model, this perfect 7-layer blueprint, but I gotta let you in on a little secret. As beautiful and as logical as it is, it's not actually what the internet runs on. In the real world, we use something a bit more streamlined. Don't get me wrong, the OSI model is still incredibly important. It's the absolute best way to learn networking and to design systems. But the internet wasn't really designed in a lab. It kind of grew organically. And as it grew, it ended up relying on a more practical 4-layer model that just smushes some of the OSI layers together for the sake of efficiency. And that model is called the TCP/IP model. This is the one that's actually doing the work out there. As you can see, it maps pretty cleanly to the OSI model. It's just squished. The top 3 layers of OSI, application, presentation, and session, they all get bundled into one application layer in TCP/IP. And at the bottom, the physical and data link layers are combined into what's called the network interface layer. So here's the absolute key takeaway. The OSI model is the perfect theory. It's the reference guide that tells you what each part of the network should do. The TCP/IP model, on the other hand, is the gritty reality. It's the practical implementation that describes how the internet actually gets the job done, using the protocols it was built on, like TCP and IP. The analogy I love is this. OSI is the beautiful, detailed architect's blueprint. TCP/IP is the tough, battle-tested building that's actually been standing and working for decades. So you might be wondering, okay, why? Why all this complexity? Why bother with all these layers? And that's a great question. The answer is that this layered approach, this is the secret sauce. It's the genius that makes the entire internet so powerful and so resilient. I mean, think about the advantages. First, standardization. It means different companies can build their own gear and software, and it'll all just work together. Then there's troubleshooting. If your internet goes down, you can pinpoint the problem. Is it a physical issue like a cut cable at layer 1? Or is it a software bug up at layer 7? It makes fixing things way easier. And maybe the biggest one, modularity. This means we can completely invent brand new Wi-Fi technology at the bottom layers, and it doesn't break a single thing for the web browsers working at the top. It is an unbelievably robust design. So next time you click send, just for a second, think about it. Think about that incredible invisible dance your data is doing. A 7-layer journey down, a trip across the globe, and a 7-layer journey back up, all in less than a blink of an eye. It's this incredibly elegant, hidden architecture that connects all of us. Knowing that this is all happening with every single click, what does that make you think about the invisible world that really binds our modern lives together?